Let's go, Max.
All right.
So I think just this one.
Yep.
And then you're ready to go.
So we haven't tested the mics. Can you hear me in the back? So that might help, and I will try to project. I want to thank you for letting me talk and start with a caveat, which is I handed in my slides to Suzanne on time on December 2nd, and then I rehearsed and I came and I did my presentation today in the last slot from 3:30 to 5, and at the end of my presentation I was reading the feedback and I realized I had been too flippant with my Ignite, and I wanted to make it more serious, so between 5 and 7:20 I rewrote it. So thank you so much for listening. Wish me luck. When I was in high school, I played the bass in the orchestra. My music didn't look like this. There were a lot more rests. I spent a lot of time counting rests and a lot of time getting lost counting rests. And I remember this one dress rehearsal, and the conductor stopped everyone and said, "Max, you're lost." And I said, "How do you know I wasn't even playing?" And she said, "You were staring at your music. You were looking at it like it was going to tell you the answer. When you get lost playing in an orchestra, the worst thing you can do is look down and stare at your music. What you need to actually do is look up and listen. The conductor can help you figure out where you are and when to come in, and that helps you listen to what's going on around you." That advice must have stuck with me, because almost 15 years later, I was doing a workshop for teachers. And it was a workshop where the teachers didn't really know why they had to be there, and I didn't really know why they had invited me to be there. And so it didn't feel like it was going well. And they looked tired. When I asked questions, I heard crickets. When they talked, it was off task, sometimes to the point of being insulting and class clownish. So I thought, clearly, this is a disaster. And the more it went badly, the more I looked at my notes, which I had scripted out so carefully. At 10:30 we're going to be talking about this, and at 11 we're going to be talking about this, and at 11:15 we'll be here. And so the more badly behaved they got, the more I'm like looking at my notes, and I must have started to sound like the teacher from Charlie Brown, because I was like, okay, in order to be here by 10:30 I have to talk about this and I have to make it last this long. Because basically I didn't want them to talk anymore based on what they had said when I let them talk. I got immediate feedback from them. We gave them an online thingy to fill out, and there was this theme of what they thought actually went well. They thought things went well, and what they wanted more of, and it was interaction. And what I realized was the same thing had happened to me when I was in orchestra, is that when I got lost, when it wasn't going well, I stared at the printed page, like that was where the answer was going to come from. This thing that's been scripted out for me, that will tell me what to do. So I was going to then say, and now I've learned this amazing way to plan, and I know how to like get people talking so I can listen. And it's true, I've gotten a lot better at it since that workshop. But reading my reflections and the feedback that I got from today's talk, I realized that the path from anything towards student-centered is a really complicated and circuitous path. And to give you guys aphorisms doesn't help us talk about what makes this so hard. I think to be thought of as professionals, we need to do a better job of talking about the really hard thinking we do. So things like just these aphorisms that you stick on your doorway, like just shut up, listen to the students, listen to, don't listen for, they make for really good Ignite talks, but they don't necessarily honor what's so hard about this kind of teaching. And I think one thing that's so hard is we have a lot of data and information about the one path from A to B, how to get students from concept A to procedure B, or known concept A to unknown concept B. Most of our curriculum materials, our textbooks, our tasks, treat the other paths like the mysterious parts on explorers' maps. We haven't explored and mapped out that terrain. And so what that means for the teacher is that we don't know what a reasonable and useful outcome is for each path in one day's time. We don't know how to recognize, okay, this is the path that this group of students is on, and I can get them here today, and that's an okay stopping point. And so we end up rushing through the summing up. We end up spending too much time listening. We let the student conversations go on because we need to hear something we think will give us some information. And then we run out of time and we talk too much because we don't know how to get the students to have that aha moment. So we end up with a situation where having the consensus comes from the students is in opposition to the consensus being super useful. And it doesn't actually have to be that way. Our students are capable of coming up with these, but only if we know what the reasonable consensus for that group is. I don't know if it's possible to resolve that tension the first time you teach a student-centered or an inquiry lesson. And I don't know what we should do about that. I think that what it means is we should teach student-centered lessons, and then we should talk about how we are still lost after that lesson. We should talk about what didn't go well. Some people who are doing it on the internet are the folks at productivestruggle.wordpress.com. It's for teachers to share the struggles that's been productive with them, so please check it out.
Oh my God, a math form, just thrown it down. Speakers, I hope you are up to the challenge.
In a pocket or on your pants. Take a choice.
You know, I don't have a pocket.
Yes,
it's fine right there.
Offering a book, and the
Does that work?
book is available from
Do I just hold this one?
Press, and the official title of the book is
Can you hold that?
Powerful problem solving, activities for sense making with the mathematical practices.
That's what I am trying to do. You know, you have to be max and you get that time
Hold that
left.
if you want.
But you should go to Heinemann.
Put this on my
pants.
Amazon and
You look
check
like
out
Bionic
Max's
Man.
book.
I know, right?
The easiest way to find it is maybe mathematical practices.
So I'm not
Max,
sure if they
Ray,
told you,
and,
but I
Max
added
is,
extra slide that's the
he's a
first
superstar,
page,
a new
so
superstar
that
in
when
our,
you push the
community.
space bar,
Okay.
this title page will show. And
Are
you
we
have
ready?
So when I
Those, yeah,
Right.
and that gives you the 20 slides.
Almost.
Okay,
So just space bar and go.
great.
Okay. Number 2 on tonight's Ignite is
The box.
Megan Taylor. Now, Megan, that's a pretty good.
Seriously, it's only downhill from here, I think, after that.
Megan is from Sonoma State University. Thank you.
I'm not sure, so how's the sound in the back for this? Good, okay. So this is, I really should call this my broken record Ignite, even though this is my first one, because this is a subject that anybody who knows me knows I talk about all the time and I feel very passionate about. And it's this idea of the teacher-proof curriculum, which is this derogatory term that I'm hoping to provide an alternative to. And my alternative is the curriculum-proof teacher. And I'm going to tell you a little bit about who this teacher is. And I want to start by quoting Robert Moses and Paul Cobb from Radical Equations. They say, if you're struggling with an equation while doing your algebra homework, more likely your parent will look over your shoulder, wrinkle a brow, and say something like, I never got that stuff either, try not to fail. In effect, math instruction weeds out people. And I think one of the reasons why math instruction weeds out people is because we perpetuate this belief that no matter what teacher you have, if you have the perfect curriculum, kids are going to learn. Look, these kids are so happy and smiling because they had the perfect curriculum even though they had a zombie for a teacher. So clearly the curriculum is the big deal. But there's problems with this, as everyone in this room knows. No perfect curriculum yet exists. There's huge variability in how teachers use curricula. And most importantly, we know teachers make a difference. In fact, we know they make the difference in how students learn. And curriculum-proof teachers design effective learning experiences regardless of the textbook they're using. They attend to different kinds of knowledge. They maximize the effectiveness of the textbook that they have. And specifically, they think about ranges of student understandings and using assessment in better ways. And Jerome Bruner really talks about these ranges nicely. He says, intellectual activity anywhere is the same, whether at the frontier of knowledge or in a third grade classroom. The difference is in degree, not kind. As an example of that, if I told you I want you to draw a male human face, and you had 5 students do this, and I got these 5 pictures. Well, the picture on the left isn't necessarily male, it's not necessarily human, but it's not an elephant, it's not a chair, right? There's something happening there. The way that we look at standards, though, right now is very black or white, and we usually draw some arbitrary line where kids either pass or fail. But those three pictures on the left are all male human faces. They're somewhere in them. There's a lot of really fantastic understanding there. Here's another example. Here's a really typical systems of equations problem that you might see about phone plans. And a standard solve systems of linear equations exactly and approximately. Okay, well maybe a kid who did this the way that we would want them to do it, according to a checkbox, would set those two equations equal to each other, they'd solve algebraically, they'd get t equals 100 and conclude T-Bell is cheaper if you text fewer than 100 times per month. Okay, fine. But what if another student did something like this? They decide to make a table and they plug in some values for different numbers of text messages and they decide that it depends. If you don't text that much, you should get T-Bell. Lot of richness in that work, not exactly passing the standard as it's written. Or what about this student who maybe is trying to use a graphical approach, a very good approach to thinking about systems, but their precision is a little bit off. So they have parallel lines and they conclude correctly, T-Bell is always better. Well, what do we know about what that kid really knows? I try to help teachers think about these ranges from beginning understandings all the way to advanced. For systems of equations, we might think of things like being able to graph both lines, or estimating the point of intersection, or giving the solution as a coordinate, all the way up to the very advanced understandings that have to do with that, like solving a system using the elimination method, or perhaps solving a 3-equation linear system. And I think these ranges are really powerful and they're really subjective, because you're the one who knows your kids. The other piece of curriculum-proof teaching has to do with assessment. Assessment is crucial. Better assessment based on goals and these ranges of understanding, allowing all students to show what they know, and giving better feedback to us about what kids know, and better feedback to students. So here's an example of a test, maybe a test question on systems of linear equations. There's a system. You say estimate the solution using a graph, be sure to show where the solution is, find the solution, there's some points here, 9 points, yeah, that sounds good, okay, 11-point problem, I'm gonna give them partial credit if they do X, Y, and Z. Okay, that's one way to think about this. This is a very familiar kind of assessment system for math teachers. But what if you took that range I showed you before, from beginning understandings all the way up to advanced, and you put that on the test, and you have kids, when you give them their feedback back, you highlight the things that they show. So let's say a student does graphically draw the lines correctly, they do all of the algebra wrong, or they leave that blank. What if you can highlight for them that they can correctly graph both lines in a given linear system? That's powerful feedback that's really powerful for the student and powerful for you. And when you flip through the top of your tests, it's better feedback. Dan Meyer gave me these textbooks. This is Larson from before Common Core and Larson after. 2 changes. The chapter number, and they list the Common Core standards. Textbooks are not going to be our help. Thank you. Thank you, Suzanne. Thank you. I think I'm handing off these to you.
So these are on. So,
Put up your hand if you've been to the Math Forum website.
thank you.
Okay, so there are a lot of people who haven't been
We gotta
there.
work, we may have to move it down in the
So
middle.
one of your assignments between now and the next time you come to Silmar is to check out the incredible
First slide.
resources and materials.
Right, I hit space bar.
Space bar, it'll go to that, and that's when you start.
Right, when I hit my space bar, it's still on my first slide. Right.
Do you in the pocket or put it on your?
1992? For
Just like-
1992, the Math Forum has been curating lots and lots of valuable, incredible amount of valuable information that is useful and critical to math teachers in building online
Do a little quick
communities
check when
for
you're ready.
mathematics education community. And
My hands are really cold, sorry.
should check it out. Okay. Ready?
So this is where I can pee? Pee my face.
This is it's pretty rigorous what we do. We have a little blue box on the floor.
know.
You can't see it from the back, but Fawn has to stay inside of that box. If you step out of it, we cut you off and you're done. We drag you off and you can't continue. Your slides go on without you. So Our next speaker is Fawn Nguyen, and Fawn is from Mesa Union School District. Fawn.
Thank you. Suzanne didn't tell me anything about a live audience being recorded, so can you hear me okay? No? Louder?
The truth of the matter is, none of us have figured out how to turn up the volume on the sound system. So she's nice to ask. All you can do is just talk a little louder.
That's the idea. You can't hear me. All right. So my name is Fawn Nguyen, and 4 things teacher school never taught me, never warned me about. So I had to learn these things on my own over the course of 20 years in the classroom. So if you're a new teacher, hopefully it's not too late for you. Right? I grew up in Vietnam where I learned my times table. We had to stand with our palm open. The teacher would point to one of us and say 4 times 8. And if we gave the wrong answer, she would give us a sharp whack on the hand. I got hit a lot. The grading system in Vietnam was a simple ranking system. In a class of 30 kids, being ranked number 30 meant you were the dumbest. And I knew I could never be number 1, so my goal was just to be number 29 and play in the rain. I only went into teaching because I knew my chance of being admitted to med school was pretty slim. So as a compromise, I married a doctor instead. To make my mom happy, so I divorced him to make me happy. I gotta stay on the slides. I did learn from teacher school classroom management, and going into middle school that would make or break a teacher. So I got this thing down really well. I also learned to write lesson plans. I made sure I highlighted all my lesson accommodations, even though I knew I couldn't follow them. My pacing guide looks great. I just, again, don't follow it, but it's there. Teacher school did warn me about the long hours and the low pay, that I'd get sick all the time. But if I do get sick, don't be sick on a Monday or Friday because there won't be any subs available. And you know, my colleagues would hate me even more if they have to cover for my classes. So I knew about classroom management, what to do, and the long hours, and how to write lesson plans. So what 4 things did I not learn from teacher school? See, now I'm just... that kids could talk like this. That crazy parents exist. You didn't let me talk it on the last slide. And I'm not talking about the demanding one or the one who does the kids' homework, the drunk, high as a kite parent. No, none of those. I'm not even talking about any of those. It's this one, this crazy one. Her daughter was in my algebra class, and what I wanted to tell her was, she's not good in math, Mrs. Hall. It's because she's only half Asian. I got both of these lines from the same parent this year. When her son told us, "Mom, I just need to wear my glasses and I can see just fine," she then said, "Well, I meant the glare of the whiteboard." These are just a few of my favorite ones. And if you know how to respond to these, please see me after the show. I will buy you all the beer you can drink. I didn't know that I had to wear a bra whenever I go out, or that, you know, I can't buy tampons and douche within a 45-mile radius of the school, and that I can't talk to kids like this. So my principal came at the end of the day and told me, "Fawn, Danny said you called him an asshole." I said I had to correct her, and I said, "No," I said, "he acted like one. Big difference." I didn't know that kids would fight to the death for me. That's what teachers' school didn't warn me, that I would fall in love with teaching, that I would fall in love with these kids. I love these kids, and that they would all dress up in green before an Oregon game, that they came up and asked if I was okay and gave me hugs after the loss to Stanford. And again, after the awful loss to Arizona, they wrote on their shirts for me. They went all out and did the Harlem Shake with me. They went inside our home for trick-or-treating. That every day they let me know that what I do matters and that we're like an extended family. So I love my kids. And one year they decided to call me Master Win. So I said, if you're going to call someone Master, shouldn't you bow to her? And so they did. I want to capture their faces before the competition. That I also didn't know that the kids could continue to stay in touch with me. Alex and Bella are now sophomores, and they drew all the sketches for me for this presentation. So thank you, girls, and thank you. God.
Wow. A special announcement. If you are an administrator here at Mesa Union School District, you better raise her pay. There are a lot of other administrators.
My hands are cold, sorry.
I'm telling you. Wow.
Another pocket?
Are you glad I have another pocket?
Otherwise,
You let me follow her.
Okay.
you're going to be great.
Pat, you changed it. Just hang on. I added that slide so that when you start, it's really your real first slide. So, do you want me to do the space bar? Or you No, okay? I can do a space bar. Okay. I'm a teacher. Nothing scares me.
I think we have a microphone just forget you heard that.
Don't forget you heard that. That's good. We were talking over...
Hold it.
Oh, okay.
This is Pat Ballou, in case you don't know her, and Pat is from the Burbank Unified School District.
Yay, Burbank! Okay, if my pants fall down, it's because I have things in both pockets that I did not put there. And I've been mic'd twice, and I can't wait till I'm unmic'd. I really am sorry that I have to follow Fawn. I want her to know, though, that I had similar experiences growing up. I held my hand out, but the nun, she'd just whap you on the ass. You know, what can I tell you? So, all right, we're going to do this one. Right, here we go. Someone contacted me. Her name is Suzanne. And she said, will you do this Ignite thing? And I said, sure. I didn't know what it was. And then she sent me an email. And the email said that I had to do PowerPoint slides. And it was on a Mac. And I thought Macs you got at McDonald's. And they had 2 patties and a special sauce and cheese. But I sent her back and I said, I don't understand at all because I don't do PowerPoint. I was one of those speech and debate teachers that buried themselves alive the 3rd time someone got up and read a PowerPoint presentation. So instead, I'm doing standards and historical perspective because I've been around the block a few times. No, I've been around a while, and so I well understand what has happened in the past and what hopefully will be happening in the future. Because about 20 years ago, standards started. That's a math problem. And it's wrong. Oh, subtraction, big number on top. I can get this right. Big number on top, subtraction problem. There we go. That doesn't seem reasonable. I borrowed what happened. All right, the new rule is 5 ways to do one problem. Let's try it one more time. There we go. Let's count on our fingers. So, it was about 20 years ago, as I'm old, it was about 20 years ago the standards all got started, and some of us were actually somewhat excited about it. I don't know why now, but I'm sure we had a reason back then. Because we thought it would give us focus, and we thought it would give us a consistent teaching structure within the state. All right, maybe within the district. All right, maybe within our school. Somehow it didn't quite work that way, though. Things changed. I think it's called data analysis. And so it all changed into something else that really wasn't quite as pretty. I have to admit this. Yeah, okay? So if you can't figure it out, the one with the tie's the boss, and that's you down there. Because all you teachers have been hearing for 20 years is test it, test it, test it, pace it, pace it, pace it, plan it, benchmark. Why aren't you all on the same page? And this is all you've been doing. You've been hanging your head, unfortunately, and saying a page a day, a page a day, a page a day, a test on Friday, page a day, page a day, page a day, test on Friday, page a day, page a day, page a day. And that's really sad. Now, some older teachers like me, we have other ways of doing things, and they sometimes actually work. But unfortunately, new teachers don't like to listen to us. We're the ones with the doors closed, you know, so no one knows what we're doing. But they don't like to listen to us, and I can understand it because this is all you guys have heard, you know? So if you're a beginning teacher out there, all this stuff that someone fed you, throw it out the window. It doesn't count worth a thing. Close your door, find an old teacher. No, find the old teacher, then close your door. So this is the best part coming up right now. That's my granddaughter. And when I get stressed, I look at her picture because I can accomplish the world when I have a granddaughter that looks like this. I mean, come on. But now, I know, darling, we've got to get busy. Common Core. Common Core, really, I kind of like it. It's kind of neat. It is going to be more in-depth. There's a math problem in there, but you can see it. Okay, it's not going to be as shallow. We're going to have smaller textbooks, but probably a lot of crap that's thrown in. If that's not true, blame Brad Fulton because I got that information from him. And here's a smarter balanced test. And yes, we are speeding up, aren't we? Okay. New thing in test, if you haven't looked at it, is the number line. Number lines are really important in everything from K all the way up through high school. Everything has to be on a number line. Number lines are really good because they give scope and depth and Suzanne, who put this one in? Well, there is scope, there's depth, I suppose. Okay, number lines. I happen to like number lines. I never liked number lines before. It almost makes me want to go back to teaching full time so that I can work with number lines. Please note I said almost. I'm not totally crazy. But I think the most important thing is that you are here for the camaraderie. You're here because you are gurus and leaders, and here is your new power chart. This is your power chart. And to help you realize the power of this weekend and of this whole experience, we're going to sing a song, or for 15 seconds of the song, because otherwise this thing's going to go off, because you are really great math gurus and you are great math leaders, and I've been so happy to be up here, and it's really different from Palm Springs, let me tell you, besides being cold. So it's to the tune of my darling, oh my darling, oh my darling, oh my darling. Okay, all right, so it's going to be up here. All right, mathematics, mathematics, not just every now and then, solving problems, seeing doubles, watch me make a set of 10. Mathematics, mathematics, algebra, geometry, and that's all we have time for. Thank you.
Pat is an Unitited newbie. Look what she did. You can do it too.
Where's this guy going? Pocket?
Pat, I identify with you because I think you and I are unemployable. When I interviewed, I had a great interview.
Another pocket? There you go.
So you know the idea
Next speaker,
the first, your
I got
first
a job.
So when you put space on it, it'll be that one again.
It'll be that one again.
Philadelphia for 5 years.
I got you.
It's just so we can have
Fresh start. I picked the smallest school I could find.
As soon as you're gonna
Secondary
start,
school in the Emory Unified School District in
So
Emeryville.
there's two of those.
There are two.
I had an interview.
That gives you the
I
20
thought it went really well. It was an amazing interview because there was a custodian on the team, there was a student on the team, a principal, a teacher, parents. I was like interviewed by 10 people. I got it done. I thought I was just really happy. I said, I nailed that. And then I was walking out the door and the principal said, could you come over here, I'd like to talk with you. And she said, I just have one question. She said, do you have an authority problem? And I was like, how did she know? I just answered, I told her that it depends on the authority, and she turned out to be the best principal I ever had and the best colleague, so it all worked out. But Pat, I think you suffer perhaps from the same. No, I don't suffer from that at all. The difference is when she said you have an authority problem, you should have said, of course not, I'm the authority. Okay, our next speaker, number 5 in the slate, And is this your first Ignite?
Yes, it is.
This is Andrew Stadell.
There you go.
Andrew Stadell, and Andrew is a teacher at Curry Middle School.
I got to worry about the blue box. Mic check. Yes? No? Mic check. The floor is wet over here. Why is that, Fawn? Yeah. All right, so let's do this. Mic check, good? All right. It's like really loud over there, so it's so funny. All right, yeah, my name is Andrew Stadell. I like to think that I create some number sense opportunities right there in that little corner. And my Ignite talk is number sense. I don't like this game anymore. And that's a direct quote from a student. You know, they say fun things. I don't like this game anymore. That came to me straight from a student after doing an estimation challenge with my students. And each day I try and do estimation challenges with them, ranging from height to capacity to song lengths to distances to money, even toilet paper. I have no boundaries here. But that's, I don't like this game anymore. Right at me. So the student was 5 inches away from estimating the height of that tractor wheel right behind my son. And I was like, what? Denise, 4'1" is a reasonable estimate. I don't like this game anymore. Like I was bummed, but I had to encourage her. But keep in mind, this is the same kid who the previous week was like, Mr. Stadell, estimation is my favorite part of math class. Which only proves one thing, that variables are not exclusive to math. Like middle school students, especially girls, are variables, let me tell you. So I had to put a time limit on my estimation challenges because they can really get rich in the discussions. And I'm not kidding you, the next day after she says, I don't like this game anymore, the same girl says, I wish estimation were longer. Like, so I'm going to change my Ignite title on you guys and say, number sense, I changed my mind. I do like this game. Now, let's get ready for Emmanuel here. Emmanuel, love this kid. He comes in after school. I need some help. I got a box of 100 manila folders. I'm always looking for opportunities to talk number sense with kids. And I say, hey, Emmanuel, I need 80 folders out of this box. How can you quickly get 80 folders out of this box for me? He stands there. He goes, by 5s. I said, okay. Even quicker, he says, by 10s. I said, okay, so I see what he's doing. I notice I'm not asking the right question, so I said, hey, Emmanuel, how can you get 80 out of here quickly without counting all 80? And I wish I could stand here and tell you he thought of that right there, like count 20 and switch them with the 80 in the box, but I'd be lying. I'd also like to tell you that I explained the subtraction method to him and it clicked on the first try, but it didn't. I blogged about this, and Max actually followed this up with a great idea. He's like, ask a different question. Ask the kid, hey, what if you needed 99 out of that folder? So I'm asking, Max's question is a simple question that I think would have extended that number sense journey for Emmanuel. So, that's Emmanuel part 1. But let me change my title one more time. I still like this game. I love conversations like that. But Emmanuel comes after school to my class one more time. It's October. The mic just went off. And I'm like, hey, week 1, yo, Emmanuel, guess the weight of this pumpkin. Picks it up, 60. I'm like, what? 16? No, 60. 60 what? 60 pounds, he says. I said, all right, Emmanuel. How much do you weigh? He's like, I don't know. I said, I think you weigh about 120 pounds. Do you think that pumpkin weighs half of your weight? I don't know. 50? So I'm like, Emmanuel, I got a picture of my son picking up a 50-pound pumpkin here. Do you think our pumpkin looks like 50 pounds? No. 10? I said, okay. So I Google like pictures of 10-pound pumpkins, and this teacher has like a desk full of 4 pumpkins. The average weight is 10 pounds. I'm like, Emmanuel, do you think our pumpkin looks about 10 pounds? 5. So we got him there, but it took work and it was fun, but it gets better because that was week 1. All right, and guess what? Out of all my classes, I had tons of Emmanuel guesses. Like, it was kind of shocking. The pumpkin was 3.1 pounds. In week 2, I bring in a bigger pumpkin. the number of Emmanuel pumpkin guesses dropped, which was awesome, which is what I want, right? We're building number sense here, but it gets better. I had 2 6th graders that guessed 5.5 and 15.9. What an awesome opportunity here. I get to do subtraction and talk about, hey, who's the winner here, who's closest. So, hey, this has been fun. Let me talk about my environmental impact here on my Ignite talk. It was worksheet free, mnemonics free, and no state tests were Christmas tree. Look at that. Isn't that fun? In all seriousness, my real conclusion though, guys, is please use any opportunity that you have with students to talk number sense and build number sense, estimation, manila folders, pumpkins, conversations. Ask simple questions that extend the number sense journey, like, how can I get 99 manila folders out of this thing? And encourage students who don't want to play number sense game anymore, because guess what? It takes time, it takes practice, it's a work in process, and who knows, maybe they'll end up loving this game. Thank you. Right on. That was fun. Thanks.
All right.
Let you guys handle this. Clear. All right. Thank you. Awesome.
I only lasted 2 years in that job. But I took the superintendent out with me. The principal stayed. She was there. Some of you may recognize our next speaker, and we're particularly lucky to have 2 big shots from NCTM who came to Asilomar and participated in Ignite.
Yours.
And the next one, I hope you'll recognize.
You have 21
Gail
slides.
Harrell is from Michigan
So I
State
didn't make a
University.
duplicate of yours. So when you push space bar,
So what?
when you push space bar, that goes away. It goes to the first one. Is that
What?
right? So you might just start and then push the space bar when you're ready to
That is
go to
something
the
to
top.
Michigan State University. Gail Harrell. Gail is from Michigan State, and she's the past president of NCTM. Gail.
Thanks, Steve. So it's really a privilege for me to be here, especially when it's almost, the weather is just about exactly like it is back in Michigan. And so before I'm going to punch this little button here, some of you might be wondering what cats have to do with statistics, and that's what we're going to talk about. And so here's some statistical information that comes from Ann Landers, where kids aren't worth it. Comes from when cats fall off buildings, the chance of survival goes up the taller the building. And of course, we all know about kindergarten scores and what they do, how college is successful if you're in algebra. Algebra 2 is a really indication of success, and kids who have taken Algebra 2 have all these more opportunities that are going to do better things. So we really have a lot of things, but people are making decisions based on data, and they're forgetting a really important piece of this. Data is my stuff. The piece is, how was the study designed and where were the data gathered? And they make a lot of educational decisions on data. Like, my daughter did not succeed in that book. Get rid of it. My daughter didn't succeed with that teacher. I need a new teacher. This is not how I learned in Singapore or Japan or whatever. They have companies who make money, lots of money, not math for them, by selling data books about how you can master all this data stuff about teachers and classrooms, and you will improve your school. We're completely data driven. There's walls, data walls. You guys have data walls? What for? The message is that data is useful, but people ignore the variability. They ignore where it's collected and how it's being used. Statistics is not about individuals. It's not about you as an individual teacher. It's about trends. It's not about me and how much money I have in my pocket. It's about the trend about how much money we all have. It's about what's going on as we look at test scores over grade levels for groups of kids. And we're looking at trends about understanding the variability that's going on. And so when we think about this, we have to say, okay, it's not about my cholesterol level when I take a new drug. It's about what's going on overall. What can I say about this drug? What's the pattern? What's going on? So the kinds of things that we're thinking about with data that are important are in the Common Core State Standards. If we take time to think about how this might play out in our classrooms. Big, good ideas are there that we should become familiar with as we move through. Like, not everything is normal, especially our kids. I've heard enough about some of these kids to know that you guys all have really, really typical kids who aren't normal, right? So the idea here is that randomness is central. Randomness has a pattern to the way things behave that's a key part of what we ought to let kids experience when they're learning the statistics and the ideas. And that variability is kind of controlled by randomness. So again, we can learn by looking at things and simulating things. Do things happen by chance, or was there something else going on? We don't do enough of thinking about that when we make these decisions on schools. So you guys have a lot of people in your state, so this might not be, but this is in Wisconsin. A difference of 10 points on the achievement test can mean principals and teachers are fired. But the school has only got 80 kids in it. So that doesn't work. Another thing we have to think about is statistics is not mathematics. Statisticians do not do exponential regressions. We talked about that in my talk this afternoon. So there's some principles that we should be thinking about when we're teaching statistics. Important principles. Nothing is certain. The second one is my favorite. If you don't know where the data came from and what was asked, you don't know much and you can't say much. You have to know what typical behavior is before you can tell when something is not typical. Correlation is not very important. R squared is. It's not about making the plot, it's about thinking about what the plot means. So some recommendations, and when I actually put these recommendations down and was looking at them, I noticed that these recommendations could be for teaching mathematics as well as for teaching statistics. The deal is we want to be data rich, not information poor. We want to make sensible use of the data, and we want our administrators and school boards to make sensible use of the data as well. Thank you. Stay in the box. I have to get on mic. I almost left.
Thank you, Gail. And, I keep having to take a deep breath as a recovering publisher. Gail, I'll forgive you for using the term key to college success. You know I had a trademark on key to anything. But the new me says, hey, who cares, right? Okay. I think
Steve ran out of
just about everybody here knows our next rock star, Kendall Brown.
Two first pages?
The first
Kendall
one is the static one.
the executive
It's not on
director
the time.
of the California Math Project. He's getting some last-minute coaching here from the pros.
20 slides.
Do a mic check. I might need to move them in on your slides.
Yeah.
Testing. Can you hear?
I can hear you.
Okay.
All right. Kendall is stepping into the box, ready to go. Kendall.
All right. So this presentation was taken from a presentation that was done by Stephanie Graham-Rivas and Lisa Usher-Stats at the recent California Math Network meeting in Southern California that I helped them prepare, so I stole some of their slides. Did I mess up? Yeah. Okay, sorry.
It should be okay.
Okay, so cooking with data. Data helps you identify disproportionate gaps, select a focus area for you to work and prioritize the steps of an action plan. So if you're going to cook with data, effective and productive use of data requires that you disaggregate, longitudinate, and cross-tabulate, or find somebody who can help you arrange data in that way. So an example of disaggregated data, that's where we separate data by race so that we can see whether or not there are gaps. And longitudinated data, which is a made-up word, right? But it's data, looking at data over time, again, so you can see patterns and whether or not there are any gaps in the data. And then cross-tabulated data is where you do comparisons across multiple data sets so that you can see, again, whether or not there are disproportionate gaps. But it's also important what kind of data that we look at. So it's important that if we're really going to close gaps, that we look at 3 types of data: achievement data, access data, and opportunity data. So this next slide represents the K-16 STEM pipeline that leads to STEM careers, and we want to look at this data over these different, across this pipeline, right? So examples of achievement data: CST data, CELT data, pass rates, SAT, ACT exams, AP exams, KC pass rates, GPAs, and completion rates in high school. Examples of access data include access to high-quality teachers, graduation rates, dropout rates, A through G course enrollment or remedial course track rates. And then opportunity data looks at how safe and healthy schools are, whether or not there are enrichment activities, whether or not AP courses are offered, whether or not students have research opportunities or mentorship opportunities at the university level. So examples of achievement data: SAT scores, again, disaggregated by race so that we can see the gaps, right? Seconds is kind of long, right? Okay, so an example of access data: AP exam takers, again, disaggregated by race so we can see what the gaps are, where the differences are. And then opportunity data, an example of opportunity data are suspension rates, again, disaggregated by race, because if the student's suspended and they're not in class, that means they don't have an opportunity to learn, right? But we also have to be careful about how data is presented, because sometimes it can be misleading. You can look at this data and say, well, over this particular period of time, African American students actually outperformed white students, right? So it's important that we do this disaggregating, because when we do that, we'll see that while there was growth, the gaps stayed the same. And so it's not that we want to do this, we want to do this, right? We want to close the gaps while everybody's improving. So, some questions to think about. To what extent are you aware of and concerned about achievement gaps, about achievement, access, and opportunity gaps in your school and in your district? To what extent are your colleagues and other stakeholders aware of and concerned about these gaps? And lastly, what might you do to accelerate understanding and the capacity for closing gaps in your school and or district and or county? So I want to close by a quote from Reverend Martin Luther King that says, "We're faced with the fact that tomorrow is today. We're confronted with the fierce urgency of now. In this unfolding conundrum of life and history, there is such a thing as being too late. We must move past indecisiveness to action." Thank you.
One of the things I like most about our next speaker is that in addition to all of the other professional things, she has an activist advocacy agenda and has brought that to her work at NCTM. As she mics up.
You remember, you have
talking
two
about
first slides,
Hegel.
so that you have total. So this is
Peg is an Einstein Fellow.
space bar,
A lot of his advocacy
and then
work
it
comes
has the
from
same
her work
one.
as an Einstein
So
Fellow
you're
on
ready to
Capitol
start.
Hill on behalf of our mathematics education community. And Peg is currently a member of NCTM's Board of Directors. And she has another year to serve on the board, more or less. Another year to serve on the board, since she's been on the board for 2 years. Pat, when you're ready, you just have to press the space bar, take a deep breath, stay in the box.
I like all the wires.
All right.
Yeah, and don't step in the puddle because you've got all the wires on. So if the best advice that you can give to an author is to write about what you know, then the best advice you can give to somebody who's going to do an Ignite talk is talk about something you love. And I genuinely love transformational geometry. I'm actually really excited about how much of it shows up in the Common Core. No, I'm not expecting you to read that. But I'm excited because there's so many things we can do in transformational geometry that we can't do in axiomatic geometry, but that's not even really what my talk is about. My talk is actually grounded in a conversation that I followed on Twitter this year that made me really, really angry. Because it pushed me in ways that maybe I didn't want to think about, and it made me confront and think on why was it that I loved geometry? And it made me confront the fact that I didn't learn to love geometry in my own high school geometry class. I don't even know that I learned any geometry in my own high school geometry class, but at least I had arrived there already having a love of geometry, so that made me think back further to where that started. The year that I was 5½, my brother got girders and panels for Christmas. I have no idea at all what I got, because as far as I was concerned, that was mine. Fast forward a few years, and the year I was 9, I got a spirograph, and I was really fascinated by the designs on the inside cover, not because I wanted to do those, but I could use those as a key to backtrack and make sense of and make my own patterns and make my own designs. And I carried that forward into my teenage years, where I had to learn to sew because girls were not allowed to take shop, so I took home ec. So fast forward again, and I actually spent the first 15 years of my working life as an architect. And I learned a whole lot from the work that I was doing, but even more from having conversations with contractors and the way they were thinking about their work. Now, we moved coasts, and I switched careers, and I discovered that the origami that I had loved as a child, that let me build things like cranes, could now help me to build polyhedra, and in ways that let me learn about things like duality and chirality that I didn't even know about before I started building these things. And then I found fractals, and I couldn't just fold them, but I could draw them, and I could build them, and I could cut them, and I could take pieces of paper and crumple them up and make fractal dimensions that were somewhere between 1 and 2, and that blew my mind completely. And then I wandered onto the hyperbolic plane, and not the hyperbolic plane of the Poincaré disk model, because that never resonated with me, but a hyperbolic plane where I could actually draw and cut out a pentagon that was regular and had all 90-degree angles in it. And then I got addicted to zomes. We'll have another conversation about that, but it let me build huge things that were fourth-dimensional polytopes, and opened up new worlds that I could go in, and gave me the tools to go in there and find out new things and discover new adventures. So when I actually became a secondary geometry teacher, I was determined that that was the world my students were going to experience, that they were going to get a dig in and get their hands dirty and have rich conversations about what they were doing and why they were doing it. So yeah, we did stuff out of the book, and we looked at similar triangles, but we also went outside and measured shadows and figured out how tall the admin building was. And we figured out a lot of other things as well in the process. There's a lot of research that tells us how learners take things from working memory and transform it into long-term memory. I have a lot of anecdotal data that says making a mess is a huge part of that. My kids all remember the days that they spilled something all over the floor. We used M&Ms so often in my classroom that there were a couple of kids that actually did believe, I'm not making this up, that M&Ms were called that because it stood for mathematics manipulatives. We We build things because when you make something, you make sense, because if it doesn't work, it doesn't fit, and it invites you to fit something in, and when it fits in place, everything comes together, including why it worked. And if we're going to ask what if, and if we're going to give kids open questions, and if we're going to have them develop their own open questions, then we also have to give them the tools and the opportunity to answer those questions, even if it means every once in a while that, yeah, they're going to wind up drawing on the furniture. So there's a whole lot of people that seem to think right now that unless mathematics is embedded in a real world, or at least a fake world setting, that kids won't engage. I never had that problem in my classroom. When I think about transformational geometry, what I think of is that geometry has the power to transform learners into curious, creative, courageous doers, thinkers, and lovers of mathematics, because that's what it did for me.
Good thing I already knew.
Pocket.
Okay, miking up next is somebody I should recognize.
Spacebar.
I've added
Our
your
ninth
slide.
out of
So this is a
10
whole,
Ignite speaker
when you push space bar, it'll
is
be on that
Dan
one.
Meyer.
And that will be part of the
Gotcha. Thanks. Check, check.
Dan is from the internet.
Hello. This isn't part of my talk. It's just a confidence thing. That's not weird, is it? We're okay with that, right? You're here for me. So we've all got boring bits, and I'm convinced that to teach the boring bits of math, we've got to ripple kids' waters. You all have boring bits. I do also. There's different ways that we have for teaching those, for making those a little less boring. One way is to create these graphic organizers called foldables and put the boring bits in the foldable where it can be retrieved later. Or maybe we flip the boring bits, send the boring bits out of class into the home, and why kids will like them there, I'll never know if they don't in the classroom. But that's one way to do it. I want to propose a different way, and that's to look at this quote and decide if you agree with it in 15 seconds, and give me a thumbs up if yeah, a thumbs down if no. You can go kind of side to side-ish if you want to. You know, you can choose a different route here. These guys right here, they kind of walk it back a little bit and say, okay, we went a little too far. There's trivia that you don't need to have a problem to know. But this next bit is really the key to transforming the boring bits into interesting bits, as far as I can tell. This quote right here, I'll get behind 100%. Feel free to circle the unfamiliar words up there if you want to. Some middle school unfriendly words, of course. Call it like a ripple if you want to, a ripple in the brain, some kind of intellectual need for new knowledge. This is my ideal class right here. Kids come in and their minds are still. I do something, show something, say something, ask something. Their minds get rippled. Across their face goes this expression, wait, what? And then I can teach and instruct and their minds are still again. It's my ideal classroom. I know how to do this better with real world type stuff, showing a guessable, concise question that kids can not get overwhelmed by with information and structure and abstraction. It's the pure stuff that sometimes gets me down. Function vocabulary, for instance. You know, that's the sort of thing I just say to kids like, all right, you got to just write this down in your foldable or in your notebook. We'll have a binder check later. You just got to get that down somewhere. I'll grade it. I want to offer a different way of how do we create that mental ripple out of the boring stuff like that. Here's the idea, is that you and I are both looking at a graph, okay? And you type a description of your graph to me, and I to you. We switch them like that. Now, I've got to draw your description. I have a hard time with it because you don't know any of those words yet. So my graph is real miserable, and yours is of mine too. We swap the graphs back. I see how rough yours was of my description, and now I have this mental ripple. Like I want to know how to communicate better and create a better graph. Let me show you what students do with this kind of game right here. Check this out. I want you to tell me what graph is this student trying to describe right here. Can you tell your neighbor? Use your finger. You have 30 seconds. You got some time here in this one. "15 seconds. Answer's coming. Get it down. I love that last line. That last line just does it for me right there. Here it is. Nailed it? Did you get that? Ish? Oh gosh. Next one's even harder here, but look at that right there. And look at how her explanation makes so much sense to her, but she doesn't know the vocabulary yet. Her mind is rippled. Here's another one. Gets real tough. What is this person trying to describe right here? What is going on here? "30 seconds. "15 seconds. Answer's coming. It'll make sense when you see it. I swear. It makes sense to her. But she lacks the words for it, doesn't she? You had that, right? That was you? I mean, look at what she's done there. You know, it'd be nice if she said start in quadrant 3 at the start, perhaps, but she's, like, what is she doing there? She's inventing coordinates in this battleship-style structure there. Like, I love both of these. I stare at these and see in them the boring bits transformed into this mental ripple, where these students, like, they do this, and now they want to know the vocabulary we can teach them. Kid on the left there wants to know what kind of words. Tell me, what would be helpful for her? Axis, for instance, quadrant. Kid on the right would love to know how coordinates work. And so I look at this sometimes, I tell myself, like, even the bits that I thought were most boring can possibly be transformed into interesting bits by creating that mental ripple. So take what you dislike, the boring stuff, and think of times where you've had your own mind rippled by some obscure corner of mathematics. Find a way to ripple your kids' minds too. Thanks a lot, guys.
All right. So I was just thinking as I was listening, I was thinking about Gail's talk, the data-driven thing. How many of you out there, teachers out there, put up your hand if you calculate your grades using points? Okay. Put your hand up if you calculate your grades and make them accurate to the 100th of a point. All right, good. Just wondering. Okay. All right. Our next and last speaker is Annie Fetter from the Math Forum. Annie and I go way back. My first experience with Annie was riding on the back of her BMW 750. What was it?
Honda CB400.
It seemed like a 750 to me. Right. Scared the hell.
It's just the kind of girl I am, Steve.
2 a.m. Along Schuylkill River and outside Philadelphia, I'm going to talk to the Visual Geometry Project about a publishing project, and Annie was put in charge of keeping me honest and keeping me straight and didn't want to laugh and motorcycle. Anyway, Annie has been going that fast ever since, and she's been with the Math Forum right from the beginning. One of the original members of the Math Forum, was part of the team that brought the Geometry Sketchpad into the world, and is a Swarthmore alum, proud of it. Woohoo! It's the Fighting Goldfish? Not the Buckeyes. I'll hear about that later. So, Annie Fetter from the Math Forum. Thank you.
All right, so I'm going to tell 3 stories of things that have happened to me in classrooms that I think illustrate stuff that we either need to care about more or our students need to know that we care about it. All right, so the first one, I went to a school in Colorado to do a workshop with the teachers after school, and I said, hey, can I teach your geometry classes during the day? Because you have Sketchpad. So we went to the lab, and we all constructed, we were doing centers of triangles, so we all constructed centroids. So, you know, if everyone constructs a centroid, they're not that interesting, really, because they all kind of look the same. They're all sort of in the center. So then we get to the circumcenter. Everyone constructs circumcenters, and now they're talking about whose is wrong because they're different. right? Yours is wrong. You didn't follow directions. I did too. Yours is wrong. So I thought, well, this would be a great chance to get them to talk about how do circumcenters work? Why do they work the way they do? So I wrote some questions on the board. When is a circumcenter inside, outside, on the triangle? And these kids are like, well, those are dumb questions. It's so obvious. I'm like, it's not really. And this one kid is sitting there, and he's sitting there, and he's just staring off into space. And I'm like, okay. So I go over and I go, what's up? And he's like, let me get this right. You actually like math. I said, yeah, I do. And he just was like, okay. So I just left him. I said, I'm just going to leave him there for a minute. And I thought about it. I thought, he has a great teacher. He's in a good school. He's had good teachers all along. They care about him. They care about how he does it. He had never met someone who he thought actually liked math. Right? So this is really important. We want kids to be passionate about something and to see that we are passionate about it. So the first thing that we should care about more is math. Just math for math's sake. It's cool, right? Okay? All right, so I'm glad we all agree on that one. So in the second one, I'm working with some fourth graders who need to do a little bit better on the PSSA, the Pennsylvania State Test. And so I have them for 45 minutes a week. All right. Now, this one kid, we were doing some test questions. See, his paper is blank, right? So he hadn't been there the previous week. And so he thinks, oh, man, I got to copy off my neighbor, right? Because I'm supposed to have the answers, because that's what we're all about, answers, right? And I'm like, I don't really care about that. And so next thing you know, this girl, Naomi. Now, Naomi had been a pain in my butt the whole time. Okay, let me tell you. She jumps up and she says to him, stop copying. Miss Annie doesn't care if you have the right answers. She cares that you know why they're the right answers. And I'm like, oh my God, I can't believe that just happened. Like, she has not been paying any attention at all, and she totally gets it. She gets what I care about. 3 sessions, 45 minutes, and she's like, answers don't matter. The whys matter. So, and I was like, this is great. I can convince kids of this. You can convince the kids of this. So this is the second thing on our list. We need kids to know that we care about the whys. All right? That's very important. Let's go. All right? Are we all for it? Okay. All right. So this brings us to my third story. Okay, so I went into this first grade classroom and I taught a model lesson. I didn't know the teacher. I'd worked in the school a lot. 45 minutes straight out of the Everyday Math book to show them that it can be done in not a really crappy way. And 2 weeks later, I set foot over the threshold and these kids run up to me, these little first graders, Miss. And I'm like, what? And they're like, ask us what 70 plus 40 is. And I'm like, okay, so what's 70 plus 40? And these kids, like, they're about to pee their pants, okay? They're so excited. They're like, it's 110. I'm like, how did you know that so fast? They're like, well, see, there's the 70 and there's 40, and they both have a 0, and you just take the zeros off, and the 7 and the 4, that's 11. Everybody knows that. And then you put the 0 back on, and it's 110. They were just dying to tell me what was in their head, because when I was in their classroom for 45 minutes, I asked what was in their heads the whole time, and they figured that out. One time, they were like, this woman wants to know what I got in here, right? So that leads us to the third thing that is on our list of things that we really should care about more. All right, we need to care about students' thinking and their ideas. And we need them to know that we do, because that has to be the lifeblood of our classroom, right? We talk about making math relevant to kids because we're going to do it about basketball and shopping. The most relevant possible way we could do math is make it related to what is already in their heads, right? And that can be about the math because we love math. It can be whatever, but it's relevant to them because it's about their thinking, not about some artificial, fake, real world thing that we came up with. So you're all going to take a pledge with me. Are you ready? Okay. I, Annie, do solemnly swear on a Mary Dulciani textbook that I will make more obvious to my students my love of math, care and ask about the whys more often, and elicit and value more of my students' thinking and ideas. So help me, Euclid.
Right. So I've been to a lot of Ignites, and this was a good Ignite. We had 10